So the other day I spoke about introduction to calculus. Why do we have dy dx? Why is it different from changing y over changing x? So today I'm going to be introducing you to a very crucial concept, which is called the differential quotient. The differential quotient. So if I have a function saying y equals, for example, let's say we have 3x squared minus 6x plus 5. How do I find the differential quotient of this guy? And what do I mean by differential quotient really? Our differential quotient is given in this form. It's given as, so if this y, let's say y equals f of x, then our differential quotient, which let me just target dc, is going to be f of x plus ah minus f of x divided by h. So this is what differential quotient would be. So here's what we do now. The first thing we need to do is to get f of x plus h. So if y equals f of x here, we already have f of x. So let's get f of x plus h. So f of x plus h, that would be equal 3. So here we have, instead of x, we replace everything x here, we replace it with x plus h. So we have x plus h square, all squared, minus 6 multiplied by x plus h. Then we have plus 5. Now, I would like you to take note of something. Whenever you are dealing with differential quotient, you don't, whenever you say constant term in the function, a constant term that is standing alone, you might just ignore it. You don't need to bother about it because by the time you're applying this expression, it's going to actually go away. So that's a simple tip for you to save time when you're finding differential quotient. So, which implies that our differential quotient is definitely going to be 3x plus h squared minus 6x plus h plus 5. So we have plus 5 plus 5. So let me put that in a square bracket, and that's minus 3x squared minus 6x plus 5. So everything here would be divided by h. So what happens next is that we expand everything inside this parentheses. Now, so to expand everything inside the parentheses, so we have this is going to be equal to, now here's what I'm going to do. This is x plus h squared, and this is also x squared here, which have coefficient of 3. I will just put the two of them together without necessarily expanding this, because expanding this will make this whole thing look more cumbersome. So let's have something of this nature. We have 3x plus h squared. Now, since that 3 is common to both of them, so that 3 could just stay outside, and I'll have x squared in this. So 3 is common, so I'll factorize that one out. I have x plus h squared minus x squared. Then we have negative 6 here, which is also common to both of these guys. So negative 6 is factored out, and we have x plus h. What's the sign here? The sign here is negative. So when you factor out negative 6, you are left with x. So you have x in this place. And what do you notice here? 5 plus 5 minus times plus, that's minus. That will be 0. So you don't really need that anymore. And that will be everything here divided by h. So now, from this place, this is difference of two squares. And what is difference of two squares? So you remember when you have something of this nature, a squared minus b squared, it's actually going to be a minus b multiplied by a plus b. So in this case now, our a is going to be x plus h, and our b is going to be x. So let's put that. So that will be x plus h minus x multiplied by x plus h plus x. That makes sense. And finally here, you see that x minus x, they both cancel out, and we're left with negative 6h. So everything is still going to be divided by h. Now, so here we have 3 multiplied by. Now, so what is x plus h minus x? That's going to be h. And what is x plus h plus x? That will be 2x plus h. And we have minus 6. So we are almost done with our differential quotient. So this is h. Now, one next thing we can notice here is that h is common to these two terms here. So we can factor h out. So that would then leave us with 3. Then we have 2x plus h in parentheses minus 6 divided by h. So what you notice is that this h is going to cancel out, and we're left with 3 multiplied by 2x plus h minus 6. And this will be 3 times 2, that's 6x plus 3h minus 6. So this is your differential quotient, in case you have to find the differential quotient. Now, here's a bonus tip. So the bonus tip is that if we actually want to find the derivative of, so let's go back to the original function. If you remember, I said that dy dx equals limit as change in x goes to 0 of change in y divided by change in x. Now, this can actually also be applied to differential quotient because it's just like the same thing. So you can have limit as h goes to 0 of your differential quotient. Yeah. So this is also the definition of derivative. And that implies that if you apply as h goes to 0 in this place, what do you have? So you have 6x plus 3 times 0 minus 6. And that is going to be equal to 6x minus 6. And that is the derivative of that function. So turning the h towards 0 for the differential quotient gives you the derivative of it. Let's confirm if that's true. 6x minus 6. So the actual function itself is this. So if you find y prime in this place, which is the y dx, 2 multiplied by 3 is 6. Then we subtract 1 from 2, that's 1. Then when you find the derivative of negative 6x, we know that x is to the power of 1 in that place, and that will just be 1 times negative 6, that's negative 6. And 1 minus 1, that will be 0, so x to the power of 0 is 1. And this is the same thing as up there. And that is how you apply the differential quotient. If you want to see more videos like this, you can make a request, a personal request, and I'll make a video for you. And if you like this video and you'd like to see more random ones, don't forget to subscribe and follow, like and share as well. I'll see you in the next one. Bye.